in welding trade. See the machines virtually in the form of photographs and identify them by names. Understand the machinery and its parts. Know the uses of each machinery used for welding process. Now let us identify the machinery in your workshop. Arc welding transformer, oxyacetylene plant setup, MIG welding setup, TIG welding setup, plasma cutting, DC power source rectifier, pedestal grinder, submerged arc welding, electro slag welding, laser beam welding, plasma welding, thermite welding, friction welding, portable circle cutter, resistance welding, seam weld, portable cutting machine, magnetic particle testing kit, spot welding, electrode drying oven, die penetration test kit. Arc welding transformer. An arc welding transformer is a machine used for arc welding, which is a welding process that uses an electric arc to melt and join metal pieces together. Oxyacetylene plant setup. An oxyacetylene plant setup is used for oxy-fuel welding and cutting. MIG welding setup. MIG stands for Metal Inert Gas Welding, also known as Gas Metal Arc Welding, GMAW. It is also known as a Metal Active Gas, MAG process. It is used to join metal pieces together by melting and fusing them with an electric arc formed between the wire electrode and the workpiece. TIG welding setup. TIG stands for Tungsten Inert Gas Welding, also known as Gas Tungsten Arc Welding, GTAW. It is commonly used for high-quality welding applications, providing precise control and producing clean welds. Plasma cutting. Plasma cutting is a process that uses a plasma torch to cut through electrically conductive materials such as steel, stainless steel, aluminum, and copper. DC power source rectifier. A DC power source rectifier converts alternating current AC into direct current DC by using diodes or other electronic components. It is commonly used in welding applications where DC power is required, such as for certain types of arc welding processes. Pedestal grinder. Similar to a bench grinder, a pedestal grinder is a machine used for grinding, sharpening, and shaping metal objects. Submerged arc welding. Submerged arc welding SAW is a welding process that utilizes a continuously fed consumable electrode and a layer of granular flux to shield the arc and the weld pool. Electroslag welding. Electroslag welding ESW is a welding process used to join thick materials, typically plates or sections with thickness ranging from 25 mm to several meters. Laser beam welding. Laser beam welding LBW is a high-precision welding process that uses a laser beam to melt and join metal parts together. Plasma welding. Used for precise and high-energy welding, providing high welding speeds, narrow and deep weld penetration, and excellent heat control. It is used for welding metals including stainless steel, aluminum, and titanium. Thermite welding. Also known as exothermic welding, it uses a chemical reaction to join metal parts. It is commonly used in railway applications for welding rails together and is known for its high strength and durability. Friction welding. This process creates a strong bond between two metal parts by generating heat through friction and applying pressure. It is used in various industries for joining similar or dissimilar metals. Portable circle cutter. a tool used for cutting circular shapes in metal sheets or plates. It is commonly used in fabrication shops, construction, and metalworking. Resistance welding, a welding process that uses electric current and pressure to join metal parts. It is widely used for spot welding, seam welding, and projection welding in automotive, electronics, and manufacturing industries. Seam weld, a type of resistance welding used to create continuous welds along the length of a joint, commonly used for joining sheets or tubes in industries such as automotive and aerospace. Portable cutting machine, a handheld tool used for cutting through various materials including metal, plastic, and wood. It is normally used in construction, metal fabrication, and demolition work. Magnetic particle testing kit, a kit used for non-destructive testing to detect surface and near-surface defects in ferromagnetic materials. It utilizes magnetic fields and magnetic particles to identify flaws in components. Spot welding, a resistance welding process used to join two or more metal sheets or parts by applying heat and pressure at specific points. It is widely used in the automotive industry for joining sheet metal parts. This process is used for the similar and dissimilar metal joining. Electrode drying oven, used for drying and storing welding electrodes to prevent moisture absorption, ensuring the quality of the welding process. Die penetration test kit, a kit used for non-destructive testing to detect surface defects and discontinuities in materials. It involves applying a colored dye and examining the surface for penetrations indicating flaws in the material. Now let us discuss the important points in identifying the machines used in the trade. Repeated reading of machinery and its name is useful for identifying the machines. Practical knowledge of handling the machine will enhance the machine usage. Point out important usage of the machine before using it. Handbooks of machines will always be helpful for the beginners.
Recap. Let us do a quick recap of what you have learned from this topic. Identify the machineries used in welding trade. See the machines virtually in the form of photographs and identify them by names. Understand the machinery and its parts. Know the uses of each machinery used for welding process. Thank you, students. Let us meet in the next session. Bye. Hello, welcome students. In this topic, you are going to learn about the welding trade, safety equipment and their uses.
Objectives. At the end of this exercise, you shall be able to identify the safety equipment. Mention the name of the safety equipment. Mention the uses of the safety equipment. Record the name and uses of respective safety equipment details in the table. Now let us look at the safety equipments. Fire/flame resistant clothing. Aprons. Rubber-soled safety boots, safety shoes. Insulated gloves or chrome leather gloves. Welding helmet. Hand shield. Goggles. Earmuffs or earplugs. Respirators. Let us see the preparation for identification of safety equipment and their uses. Task 1. Read and interpret the personal protection equipment visually on real devices or from the charts. Fire or flame resistant clothing. Aprons. Rubber-soled safety boots or safety shoes. insulated gloves or chrome leather gloves, welding helmet, hand shield, goggles, earmuffs or earplugs, respirators. Task 2. Identify and select the personal protection equipment suitable for a particular type of protection.
Protects from
Flying particles or debris. Kits welding helmet. Fumes and oxides. Hot slag, sparks. Goggles.
protects from
Heat, fires. Kits, fire or flame resistant clothing.
protects from
Noise, earmuffs or earplugs.
protects from
Electric shock, insulated gloves or chrome leather gloves.
protects from
Burns, rubber-soled safety boots or safety shoes. Now let us see the hazards and the respective safety equipment used in the welding process. Write the name of PPE to corresponding type of protection.
to protect from
Heat, fires. Kits, fire or flame resistant clothing.
to protect from
Kits, aprons.
to protect from
Electric shock, heat, burns, fire. Kits, rubber-soled safety boots or safety shoes.
to protect from
Electric shock or heat. Kits, insulated gloves or chrome leather gloves.
to protect from
Flying particles or debris. Kits, welding helmet.
to protect from
Irritation and chemical burns. Kits, hand shield.
to protect from
Intense light. Kits, goggles.
to protect from
For noise. Kits, earmuffs or earplugs.
to protect from
Fumes and oxides. Kits, respirators.
Let us do a quick recap of what you have learned from this topic. Identify the safety equipment. Understand the safety equipment. Uses of safety equipment. How to record the name and uses of respective safety equipment details in the table. Thank you, students. Let us meet in the next session. Bye-bye. Hello and welcome, students. In this topic, you are going to learn about how to perform hacksawing, filing square to dimensions.
Objectives. At the end of this exercise, you shall be able to identify the various parts of bench vise, how to use the bench vise, describe the method of hacksawing, filing to maintain squareness and dimension of edges. Now let us see the tools and equipments required for hacksawing, filing square to dimensions. Marking media, steel ruler, scriber, prick punch or dot punch, ball peen hammer, flat file, bench vise, hacksaw, tri-square, personal protective equipment PPE. Check the pre-machined size of 75 mm length and 75 mm breadth using a ruler. Use marking materials 82 mm maintaining side B mark. Similarly, mark 82 mm on side E. Punch the marked line. Hold the job in the benchwise, keeping 10 mm away from the marked line. Make the notch on the line to start hacksawing. Cut along the marked line. Similarly, cut on the other side. Apply pressure in the forward stroke. Release the pressure in the return stroke. Use full length of the blade while sawing. Clamp the job to allow sawing towards the overhanging end. Clamp the job to be cut according to the cross section for sawing. Hold the job as flat or as long as you can so that it can be cut rather than the edge. Tighten the jaws firmly to avoid tilting and shifting of the job. Clamping needs improvement to reduce chattering and vibration. Now let us see how to perform filing and to maintain square dimensions. Task 1. Hacksawing. Select the correct pitch blade for cutting. Shorter the cutting section, the finer the blade pitch. Make sure that at least 4 teeth are cut at a time. Harder the material, the finer the blade pitch should be. Fix the blade such that the cut direction is towards the teeth. The wing nut is used to tighten and tension the blade. As long as only a few teeth are cutting, use a small amount of downward palm pressure. Only when cutting forward, use downward pressure. Use the full length of the blade in order to avoid early dulling of the teeth in the middle portion of the blade. Move the blade strictly in line with the marked direction. Avoid tilting the frame during cutting because doing so could cause the blade to bend and shatter suddenly. Cut from the opposite side if deviation exceeds the marked line. To avoid breaking the blade and hurting yourself, cut slowly while finishing the cut. Task 2. Filing square to dimension. Check the height and the benchwise to select a platform or another workbench. Hold the job in the benchwise with a projection of 5 to 10 mm from the top of the vise jaw. Select the files of various grades and lengths according to the size of the job, quantity of metal to be removed, and material of the job. Verify that the file's handle fits tightly. Using the palm of your right hand, press the file forward while holding the file's handle. Hold the tip of the file according to the quantity of the metal to be removed. For heavy filing, for light filing. For removing the local unevenness, draw filing can also be done. The same filing can also be done for fine finishing. Start filing by uniformly applying pressure to the file while moving forward and releasing it while moving backward. Give a few more strokes to make sure that the file always stays flat and straight across the surface to be filed. Balance the file's pressure. Checking flatness. Use the blade of the tri-square as a straight edge for checking flatness. Place the blade of the tri-square on the surface to be checked in all directions so as to cover the entire surface. Do the checking phase. The light gap will indicate high and low spots. Checking squares. Consider the large finished surface as the reference surface. Ensure that the reference surface is filed perfectly and is free from burrs. Butt and press the stock against the reference surface. Bring down slowly and make the blade touch the second surface with which the squares are to be checked. Light gap will indicate the high and low spots.
Let us do a quick recap of what you have learned from this topic. Identify the various parts of bench vise. How to use the bench vise. Describe the method of hacksawing. How to do filing to maintain squareness of the edges and maintain the dimension. Thank you, students. Let us meet in the next session. Hello and welcome, students. In this topic, you are going to learn about marking out on MS plate and punching.
Objectives. At the end of this exercise, you shall be able to prepare the job as per size 150 mm length, 100 mm width and 3 mm thickness. Explain what is marking media, copper sulfate or chalk powder solution. Explain how to put a straight line using steel ruler and scriber. Describe the uses of prick punch and pitch. Tools required for marking out on MS plate and punching. Marking media, steel ruler, scriber, prick punch or dot punch, ball peen hammer, flat file, bench vise, hacksaw, tri-square, personal protective equipment PPE. Now let us see the preparations for using media marking on MS sheet. Take a 3 mm thick MS sheet for this job work. Clean the sheet with wire wool and remove the dirt and dust on the sheet. Mark the cutting edge of the job as per size 150 mm length, 100 mm width and 3 mm thickness. Use the shearing machine to cut the job piece according to the marked size. Check the edges for smoothness. Make the square edges by filing. Check the squareness using tri-square. Keep the job prepared for punching and marking after the testing the squareness. Apply copper sulfate or chalk powder solution and allow it to dry. Keep the sheet in flat position on the workbench or work table. Using steel ruler and scriber point, mark points A, B, C, D, E and F from the 150 mm long edge of the job at 10, 25, 40, 55, 70 and 85 mm distances. Similarly, mark points A1, B1, C1, D1, E1 and F1. The edge of the steel rule may have been damaged. To avoid wrong measurement, coincide or set the first or second cm graduation mark of the steel rule against the 150 mm long edge of the job for taking measurements and marking of points A to F and A1 to F1. Ensure there is no parallax error while using the scale to mark the points A to F and A1 to F1. Using the steel ruler and scriber, draw the lines AA1, BB1, CC1, DD1, EE1 and FF1. Draw towards you while tilting the scriber in the direction of the stroke. Punch small holes on each of the 6 lines with the dot punch and hammer. While hammering, hold at the extreme end of the handle. Visually check the marked lines for parallelism and correctness. Pitch is the distance between the 2 consecutive dots.
Let us do a quick recap of what you have learned in this topic. Prepare the job as per size 150 mm length, 100 mm width and 3 mm thickness. Explain what is marking media, copper sulfate or chalk powder solution. Explain how to put straight line using steel rule and scriber. Describe the uses of prick punch and pitch. Thank you, students. Let us meet in the next session. Bye. Hello, welcome students. In this topic, you are going to learn about performing fusion run without filler rod on mild steel MS sheet, 2 mm thick in flat position using oxyacetylene welding process.
Objectives. At the end of this exercise, you shall be able to mark and cut the MS sheet pieces of size 150 mm length, 50 mm width and 2 mm thickness using a hand lever shear. Set the oxyacetylene gas plant and fit the correct size nozzle in the torch. Set gas pressure according to the nozzle size. Perform the fusion run without the filler rod in flat position using leftward technique. Clean the weldment and visually inspect for weld defects. Now let us look at the tools and equipments required for performing fusion run without filler rod on MS sheet 2 mm thick in flat position. Steel ruler, scriber, ball peen hammer, hacksaw, flat file, bench vise, tri-square, tongs, chipping hammer, steel wire brush, personal protective equipment PPE, nozzle number 3, oxygen and acetylene plant setup, wedding torch, spark lighter, cylinder key, nozzle cleaner. Now let us see the pre-welding preparation for performing fusion run without filler rod on MS sheet 2 mm thick in flat position using oxyacetylene gas welding process. Use an MS sheet of 2 mm thickness for this job work. If there is any rust, remove it with a wire brush and emery paper. Do not rub with heavy pressure on the wire brush. Use the emery paper rolled on a piece of wood while cleaning. Remove paint, oil or grease by dipping the MS sheet in a solvent of dilute hydrochloric acid. Apply marking media over the MS sheet. Use a steel ruler and scriber to mark the MS sheet with measurements of 150 mm length, 50 mm width and 2 mm thickness. Cut the MS sheet by using a hand lever shear according to the drawn line. File and finish the sheet to dimensions as per drawing. At a distance of 10 mm from one edge, draw lines parallel to the sheet's longer edge. Punch parallel lines on the sheet surface as per sketch. Set the job piece on the welding table in flat position with fire brick support. Select and attach nozzle number 3 to the blowpipe. Wear safety apparels and gas welding goggles. Now let us see the process for performing fusion run without filler rod on MS sheet 2 mm thick in flat position using oxy-acetylene gas welding process. Set acetylene pressure 1 kg per centimeter square and oxygen pressure at 0.1 kg per centimeter square on the regulators. Ignite the oxy-acetylene gases and adjust the neutral flame. Hold the pipe on the job at its right hand end at the required angle. Hold the blowpipe and flame in the correct position angle for proper fusion. Hold the blowpipe and flame in the correct position angle for proper fusion. There is less fatigue to the hand of the operator. The angle of the nozzle with the welding line is between 60 and 70 degrees. The angle between the nozzle and the job surface should be 90 degrees. The blowpipe should be positioned so that it is parallel to both the operator and the sheet's punched lines. The blowpipe should be moved from right to left while keeping a constant speed and a blowpipe angle. Keep the molten pool on the punch line. Avoid excessive concentration of heat at any point. If the metal becomes too hot, lift the blowpipe momentarily away from the molten pool. Do not touch the inner cone with the molten pool to avoid backfire and flashback. Keep the molten pool in the correct size by adjusting the rate of travel and giving slight circular motion to the blowpipe. Quickly lift and blowpipe at the left end. Extinguish the flame and cool the blowpipe in water. Use tongs while handling hot jobs. Clean the fuse surface with a steel wire brush. Visual examination can be done to ensure uniform width, ripples and proper depth of fusion penetration. If the speed of travel and blowpipe motion are correct, the fusion runs will appear with uniform width and even ripples. Repeat the above to achieve uniform fusion and better manipulation of the blowpipe.
Let us do a quick recap of what you have learned from this topic. Mark and cut the MS sheet pieces of size 150 mm length, 50 mm width and 2 mm thickness using a hand lever shear. Set the oxyacetylene gas plant and fit in the correct size nozzle in the torch. Set gas pressure according to nozzle size. Perform the fusion run without the filler rod in flat position using leftward technique. Clean the weldment and inspect visually for weld defects. Thank you, students. Let us meet in the next session. Hello, welcome students. In this topic, you are going to learn about performing fusion run without filler rod on mild steel MS sheet, 2 mm thick in flat position using oxyacetylene welding process.
Objectives. At the end of this exercise, you shall be able to mark and cut the MS sheet pieces of size 150 mm length, 50 mm width and 2 mm thickness using a hand lever shear. Set the oxyacetylene gas plant and fit the correct size nozzle in the torch. Set gas pressure according to the nozzle size. Perform the fusion run without the filler rod in flat position using leftward technique. Clean the weldment and visually inspect for weld defects. Now let us look at the tools and equipments required for performing fusion run without filler rod on MS sheet 2 mm thick in flat position. Steel ruler, scriber, ball peen hammer, hacksaw, flat file, bench vise, tri-square, tongs, chipping hammer, steel wire brush, personal protective equipment PPE, nozzle number 3, oxygen and acetylene plant setup, wedding torch, spark lighter, cylinder key, nozzle cleaner. Now let us see the pre-welding preparation for performing fusion run without filler rod on MS sheet 2 mm thick in flat position using oxyacetylene gas welding process. Use an MS sheet of 2 mm thickness for this job work. If there is any rust, remove it with a wire brush and emery paper. Do not rub with heavy pressure on the wire brush. Use the emery paper rolled on a piece of wood while cleaning. Remove paint, oil or grease by dipping the MS sheet in a solvent of dilute hydrochloric acid. Apply marking media over the MS sheet. Use a steel ruler and scriber to mark the MS sheet with measurements of 150 mm length, 50 mm width and 2 mm thickness. Cut the MS sheet by using a hand lever shear according to the drawn line. File and finish the sheet to dimensions as per drawing. At a distance of 10 mm from one edge, draw lines parallel to the sheet's longer edge. Punch parallel lines on the sheet surface as per sketch. Set the job piece on the welding table in flat position with fire brick support. Select and attach nozzle number 3 to the blowpipe. Wear safety apparels and gas welding goggles. Now let us see the process for performing fusion run without filler rod on MS sheet 2 mm thick in flat position using oxy-acetylene gas welding process. Set acetylene pressure 1 kg per centimeter square and oxygen pressure at 0.1 kg per centimeter square on the regulators. Ignite the oxy-acetylene gases and adjust the neutral flame. Hold the pipe on the job at its right hand end at the required angle. Hold the blowpipe and flame in the correct position angle for proper fusion. Hold the blowpipe and flame in the correct position angle for proper fusion. There is less fatigue to the hand of the operator. The angle of the nozzle with the welding line is between 60 and 70 degrees. The angle between the nozzle and the job surface should be 90 degrees. The blowpipe should be positioned so that it is parallel to both the operator and the sheet's punched lines. The blowpipe should be moved from right to left while keeping a constant speed and a blowpipe angle. Keep the molten pool on the punch line. Avoid excessive concentration of heat at any point. If the metal becomes too hot, lift the blowpipe momentarily away from the molten pool. Do not touch the inner cone with the molten pool to avoid backfire and flashback. Keep the molten pool in the correct size by adjusting the rate of travel and giving slight circular motion to the blowpipe. Quickly lift and blowpipe at the left end. Extinguish the flame and cool the blowpipe in water. Use tongs while handling hot jobs. Clean the fuse surface with a steel wire brush. Visual examination can be done to ensure uniform width, ripples and proper depth of fusion penetration. If the speed of travel and blowpipe motion are correct, the fusion runs will appear with uniform width and even ripples. Repeat the above to achieve uniform fusion and better manipulation of the blowpipe.
Let us do a quick recap of what you have learned from this topic. Mark and cut the MS sheet pieces of size 150 mm length, 50 mm width and 2 mm thickness using a hand lever shear. Set the oxyacetylene gas plant and fit in the correct size nozzle in the torch. Set gas pressure according to nozzle size. Perform the fusion run without the filler rod in flat position using leftward technique. Clean the weldment and inspect visually for weld defects. Thank you, students. Let us meet in the next session. Hello, welcome students. In this topic, you are going to learn about setting up arc welding machine and accessories and striking an arc.
Objectives. At the end of this topic, you will be learning to set the SMAW machines by connecting the welding cables between the welding machine electrode holder. Start and operate the controls and stop the welding machine in sequence. Set welding current strike and maintain the arc. Deposit uniform straight line bead in flat position. Clean and inspect the weld surface. Now let us look at the tools and equipment required for SMAW. Steel ruler, scriber, prick punch or dot punch, ball peen hammer, flat file, bench vise, tri-square, tongs, chipping hammer, steel wire brush, personal protective equipment PPE, SMAW welding machine, electrode cable, earth cable, electrode holder, welding electrode, ground clamp or earth clamp, welding table, C-clamp, rectifier. Now let us see how to set up an arc welding machine and accessories to strike an arc. Set the workplace with proper lighting and good ventilation. Set the power switch earthing from the main line to the suitable setting for power supply. Keep the welding table convenient under proper lighting. Keep the arc welding machine near the power source and connect the power cable to the main switch. Connect the electrode cable to the machine. Connect the earth cable to the machine. Fix the earth cable with ground clamp and clamp it to the welding table. Connect the welding electrode to the cable. Keep the necessary tools at a place where it should be easy to handle. Wear personal protective clothing. Turn on the arc machines and ensure the power source and earthing are proper. Set the current amperage as per the suggested list on the machine. Keep the MS plate on the welding table. Start the process of striking an arc. Now let us see the setting up of arc welding machines and accessories and striking an arc. Clean the given scrap iron plate surface with a steel wire brush. And also clean for any oil or grease, water and paint on the scrap iron plate. Keep the MS plate in flat position on welding table. Fix a 3.15 mm dia medium coated mild steel electrode in the electrode holder. Make sure the flux coated electrode's bare wire end is firmly seated in the electrode holder's slot or groove. Set 110 amps for the 3.15 mm dia electrode. The current values for various size electrodes are provided by electrode manufacturers and can be used as a reference when setting currents. Every time a welder needs to start welding, change an electrode or stop an arc while welding, they must first strike the arc. Connect the electrode to negative if the machine is a DC welding machine. Hold the electrode about 5 mm above the job piece at one end and 75-degree angle to the line of weld and 90-degree angle to the plate surface. We will now see how to perform the scratching method. Strike the arc by dragging the electrode quickly and softly across the welding job using wrist movement only. For a few seconds, pull the electrode back from the surface to a distance of about 6 mm, then lower it to a distance of about 3 mm to keep the arc in place. To break the arc quickly, withdraw the electrode up. We will now see how to perform the tapping method. Strike the arc by moving the electrode down to touch the job surface lightly. To maintain a proper arc, carefully lift the electrode from the surface to about 3 mm and then lower it to about 6 mm for a few seconds. The tapping method is most recommended as it does not put pit marks on the job surface. To prevent it from overheating or spoiling, the electrode should be quickly released by twisting the wrist if it freezes to the plate. Use chipping goggles or chipping screen while deslagging or while removing slag on the welds. If the welded job is small in size, use tongs to hold a hot job. Strike the arc on the scrap MS plate several times until the electrode can be struck each time without freezing.
Let us do a quick recap of what you have learned from this topic. Set the SMAW machines by connecting the welding cables between the welding machine, electrode holder. Start and operate the controls and stop the welding machine in sequence. Set welding current, strike and maintain the arc. Deposit uniform straight line bead in flat position. Clean and inspect the weld surface. Thank you, students, and let us meet in the next session. Hello and welcome, students. In this topic, you are going to learn about depositing straight line bead on an MS sheet, flat position using oxyacetylene welding process.
Objectives. At the end of this module, you will learn to cut the MS sheet as per size 150 mm length, 100 mm width and 3 mm thickness. Select the filler rod for oxyacetylene welding process. Set the pressure of both the gases as per the specification. Clean and inspect the weld surface for any defects. Now let us look at the tools and equipment required for OAW process. Steel ruler, center punch or dot punch, ball peen hammer, angle grinder, half round file, bench vise, tri-square, chipping hammer, steel wire brush, safety clothing, gloves, PPE kit, nozzle number 5, CCMS filler rod 3 mm, OAW setup, cylinder key, tip cleaner, spark lighter, gas welding goggles. For depositing straight line beads on an MS sheet in flat position using OAW process. Take an MS sheet and apply marking media. The size is 150 mm length, 100 mm width and 3 mm thickness. Cut the MS sheet as per the size 150 mm length, 100 mm width and 3 mm thickness. Keep the MS sheet on the table and scribe straight lines using a ruler. Do the dot punch marking over the straight lines. Clean the surface of the sheet for oil and rust. Select number 5 size nozzle and fix it to the blowpipe. Select a 3 mm dia CCMS rod. Set 0.15 kg per centimeter square pressure for oxygen and acetylene gases. Ignite the blowpipe and set neutral flame. Deposit the weld in flat position. Use leftward technique for depositing straight line beads. Now let us see the welding process for depositing straight line beads on the MS plate in flat position using OAW process. Deposit the weld bead starting from the rightmost point of a punched line and moving left along the line. Hold the blowpipe at 75 degrees and the filler rod at 30 to 40 degrees to the line of the weld. The angle between the blowpipe nozzle and filler rod and the sheet surfaces should be at 90 degrees. Make sure there is a minimum melting of the base metal and filler rod as possible. Maintain proper angles for the blowpipe and filler rod. Move the blowpipe and filler rod without any side-to-side movements. Move along the marked line at a uniform speed in the leftward direction. Do not allow the inner cone of the flame to come in contact with the molten metal to avoid backfire. Complete depositing the weld bead up to the top end of the line and ensure to fill the crater. Ensure to avoid undercut defects by proper manipulation of the blowpipe and the filler rod. Clean the bead and visually inspect for any surface or external defects.
Recap. Let us do a quick recap of what you have learned from this topic. Cut the mild steel MS plates as per size 150 mm length, 100 mm width and 3 mm thickness. Select the filler rod for oxyacetylene welding process. Set the pressure of both the gases as per the specifications. Clean and inspect the weld surface for any defects. Thank you, students. Let us meet in the next session.